Hi everybody, this is Mrs. Snook with section 6.4, rhombuses, rectangles, and squares. So we have been doing parallelograms, and now we're going to go into special kinds of parallelograms. And the first one is the rhombus. Now the definition of a rhombus is that all four sides are congruent. So rhombus implies four sides congruent. Now it's also a parallelogram. And so because a rhombus is a parallelogram, we know that the opposite sides are congruent, and as all four of them are congruent anyways, check. We know that opposite sides are parallel. The opposite angles are congruent. The consecutive angles are supplementary, and the diagonals bisect each other. So add to all of that, if it's a rhombus, the diagonals are perpendicular. So I'm going to sketch in these diagonals. I'm going to call this A, B, C, and D. And they're perpendicular to each other. So I'm going to put a perpendicular mark in there. And I can then say that line segment BD is perpendicular to line segment AC. Also add to that, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So A, B, C, D. And then what this means is that this angle here is congruent with that one. So those two angles down at A are congruent with each other. And because opposite angles are congruent, these two up here at C are also congruent to the ones at A. Same thing with B and D. That angle at B is congruent with this other angle at B. And the angles down at D are also congruent with the angles at B. So we do have a lot of properties for a rhombus. Next one is the rectangle. Now the definition of a rectangle is you have four equal angles. This is a four-sided figure. All four angles are the same. So rectangle implies four angles are congruent, which means they all have to be 90 degrees. Now the properties that this rectangle has, because it's a parallelogram, are just like the ones before. My opposite sides have to be congruent. My opposite sides have to be parallel. We know opposite angles are congruent, and since all four angles are congruent anyways, just kind of check that one off. Opposite angles congruent. We know the consecutive angles are supplementary. Let's take a look at this. 90 plus 90 equals 180. So that works. And we also know that the diagonals bisect each other. Now add to that list another fact about a rectangle, and that is their diagonals are congruent. So if a parallelogram is a rectangle, rectangle implies the diagonals are congruent. So over here in this picture, I could call this A, B, C, D, and I can say that line segment AC is congruent with line segment BD. Now the last one we're going to do today is the square. Now the square is both a rectangle and a rhombus. So because it's a parallelogram, opposite sides congruent, opposite sides parallel, opposite angles congruent. Consecutive angles are supplementary, and your diagonals bisect. Now we're going to add in the rhombus features. Not only are opposite sides congruent, all four sides congruent. And our diagonals, not only do they bisect each other, they're also perpendicular. Okay? And those diagonals bisect the opposite angles. Now, because it's a rectangle, add to all of that the fact that the four angles are congruent. And just keep in mind that means 90 degrees in this case because it's a four-sided figure. And our diagonals are also congruent. So with all of that in mind, we're going to do some brain teasers here. We're going to name all the quadrilaterals that have the given property. Now our choices are parallelogram, rectangle, rhombus, or square. First one is diagonals are congruent. So which of those have congruent diagonals? And you should be telling me rectangle. But guess what? A square is a rectangle. So add square to your list. Next one. Both pairs of opposite sides are congruent. Well, that comes from a parallelogram. So all of them. So I'm going to say parallelogram. Now a rhombus is a parallelogram. So that goes on the list. A rectangle is a parallelogram. So that goes on the list. And a square is a parallelogram. So I put all of them on the list. Diagonals bisect the opposite angles. You should be telling me rhombus. Who else is a rhombus? That's right, a square. Both pairs of opposite sides are parallel. Well, that's true of a parallelogram. And guess what? A rhombus is also a parallelogram. So is a rectangle. So is a square. All angles are congruent. Well, rectangle has all angles congruent. And so does a square, because a square is a rectangle. All sides congruent, that's a rhombus. And make sure you include a square, because a square is a rhombus. All right, so now we're going to start playing some math. Quadrilateral ABCD is a rhombus. And so number 7 says, if the measure of angle BAE is 32 degrees, so go ahead and mark it, find the measure of ECD. So measure of ECD is this angle right there that I highlighted. Okay? I did ECB instead of ECD, sorry. ECD, right there. I got the right one now. Well, check it out. A rhombus is a parallelogram. So therefore, those two are parallel. So right here, we have a transversal. Two parallel lines cut by a transversal tells us alternate interior angles are congruent. This is 32 by AIA. Okay. Now we're going to say, what if measure of EDC, so EDC is 43. Find the measure of CBA. So CBA is that big one that I just highlighted. Well, I know in a parallelogram, opposite angles are congruent, and I also know in a rhombus, the diagonals are bisecting the opposite angles. So therefore right here I have 43, which means that this angle at CBA has to be congruent to the 43 plus 43. All right, next one. If measure of angle EAB is 57, find measure of angle ADC. Okay? So rhombus means that the diagonal bisects the angles. So here's 57 there. I'm going to highlight ADC for us. And that is a consecutive angle to my 57 plus 57. So those two together are going to be supplementary with ADC. So I'm just going to do 180, and I'm going to subtract both of those 57s. And when I do that, I get 66. All right, next one. Measure of angle BEC. So that's that one right there, is 3x minus 15. Solve for x. So I'm going to do number 10 over here. So I know that the diagonals in a rhombus are perpendicular. So rhombus implies perpendicular diagonals. Therefore, 3x minus 15 equals 90. Go ahead and add 15 to both sides, so 3x equals 105. So what does x equal? I got 35. Number 11, I'm going to do here. Number 11 says measure of angle ADE. So ADE is 5x minus 8. Angle CBE is 3x plus 24. So again, I have two parallel lines cut by a transversal. So I have alternate interior angles. So I can set them together and solve. So 5x minus 8 equals 3x plus 24. And I'm doing alternate interior angles. So go ahead and I get 2x equals 32, x equals 16. And then number 12. So number 12, we have measure of angle BAD. So that's this one here, is 4x plus 14. And measure of angle ABC, that's that one over there, is 2x plus 10. We're going to solve for x. Well, guess what? Those are consecutive angles. And just recall from before, parallelogram implies consecutive angles are supplementary. So I'm going to say 4x plus 14 plus 2x plus 10 equals 180. Let's combine our like terms. So 6x plus 24 equals 180. Go ahead and solve for x. So 6x is 156. X equals 26. All right. Now let's move on to a rectangle. Now we have ABCD is a rectangle. So start thinking your rectangle properties. AC, which is a diagonal, equals 18. And we're going to find each angle measure or length. Okay. So number 13 says find the measure of angle 1. Well, bear in mind that a rectangle implies that the diagonals, not only they're bisected, they're congruent. So therefore, because they're bisected and congruent, I can mark those two congruent to each other. Now I've got an isosceles triangle. So then this angle here that's 54 degrees is congruent to angle 1. So angle 1 is 54. Now number 14, we want to know what angle 2 is. Well, rectangle says that all four angles are congruent, so we have a 90 degrees angle in there. So angle 2 is going to be 90 minus 54. And I got 36. Angle 3. Well, remember our triangle sum theorem. The two 54-degree angles, you're going to add those together along with angle 3 to get 180. So I'm just going to do 180 minus those two 54s. And I got 72. Number 16 wants to know what angle 4 equals. So right here is angle 4. That one, check this out, parallel, parallel, transversal. So angle 4 is AIA with angle 2. Angle 2 I already know is 36. So angle 4 is also 36. Angle 5. Angle 5 is AIA with angle 1. So 54. Angle 6. Couple of ways you can do this. I can say that angle 6 is a linear pair with angle 3. So I can just do 180 minus 72 gives me 108. I could say angle 6 is an exterior angle with the two 54s. So I add those up and I get 108. I could say that angle 6 is in the same triangle, and I know that 4 is 36 degrees. And these guys are congruent, so that's 36 degrees. So I can do 180 minus those, and I get 108. Lots and lots of choices here. Now let's look at some lengths. We're looking for the length of line segment AE. Let me highlight that for you. This one right there. That's what we're looking for. We know that AC is 18, and we know that in a rectangle, parallelogram, the diagonals bisect each other. So therefore, AE is going to equal 9. My justification is parallelogram implies bisecting diagonals. Now let's find BD. Here's BD. BD is a diagonal in a rectangle. And we know that in rectangles, the diagonals are congruent. So therefore, BD is the same thing as AC, which is 18. All right, that's it for today's lesson. Thank you for watching. Have a great, fantastic day.